So my name is Alex Osaki. I'm a product marketing manager at Here Technologies. Like Sean, I'm exactly as old as Here, like Sean and Gray Matter. Here was founded in 1985. We have historically focused on a lot of kind of automotive cases, so on vehicle routing. But I joined the company working in consumer applications, consumer mapping, and then we have been working as well in fleet routing. So we've been doing a lot of that kind of on the back end. So Here Technologies as a company is one that you may not necessarily be familiar with, but if you've used Amazon or Facebook, then you are familiar with our products because they use those. You've probably seen our maps if you use say Prime Now and you're tracking a delivery, which is really the context that I want to talk to you about location services. So, we heard a good overview of the different kinds of questions that might come up, the kind of location questions that you might be wanting to answer. And what I'd like to do is talk through one of those in particular. So tour planning is the problem where we have, we're trying to optimize last mile deliveries. And this is something that is extremely important. So if we look at the market, just to give you some grounding of what this looks like, the past few years have really seen a shift in the way that consumers interact with retailers. So last mile had really been seeing greater than 10%, so double-digit year-on-year growth in terms of the number of people who were looking for last mile solutions or were ordering for same day or next day delivery. And that's increased the pressure on retailers to meet those demands, because 90% of customers will, indicate that they will respond negatively to a missed ETA. That could be something as simple as demanding compensation. But 55% of customers say that they will switch to a competitor that has faster or more reliable delivery service, which means that in a world where supply chains are incompletely digitized, delivery fleets will say that digitization and transparency into the supply chain is one of their greatest problems. 49% of retailers say that customer expectations are their biggest challenge. So if you use, if you've used, again, services like Prime Now, you really have seen the way that those expectations have become more aggressive. We really expect to know exactly when our delivery is going to be is going to get there, or when a service that we've ordered. The days of the cable repairman or the plumber or the IKEA delivery person says you will be there within a 6-hour window or will be there sometime on Friday is no longer acceptable. And that's happening at the same time as there are cost pressures throughout the delivery industry. So last mile is somewhere between 40% and up, in some cases more than half the cost of delivery. And we've seen that the customer willingness to pay is lower than the actual cost. So the average cost of a last mile delivery is $10. Customer willingness to pay is only $8. Which means that businesses are in the position of having to make up that difference. And this is an industry that is already facing fairly tight margins between the need to pay drivers more to compensate for the driver shortage that you've probably seen in the news, the push towards new capital investments in electrification. The rising cost of diesel, we were spared that for 2020 as consumption decreased, but those costs have increased dramatically over the last year. And the changes that we saw before the pandemic haven't really slowed down. Obviously, as people shifted from in-person retail to ordering goods online, that led to an increase in the use of last mile delivery, so delivery services. But it's really been following the same trajectory since. And even as in-person operations have begun to reopen, we're still seeing that push towards consuming, your goods via delivery. And that's meant that there have been the need to meet that. So there's a 100% increase or more in online fulfillment for orders. But also there are knock-on consequences to that. So it says here, city traffic is slowing even outside of rush hour. Based solely on the impact of last mile deliveries, we are expecting a further 100% increase in the volume of deliveries over the next 10 years. leading to a 36% increase in delivery vehicles on the roads within urban centers and a corresponding 20% increase in traffic congestion solely attributable to those vehicles. So figuring out ways to optimize that becomes a win-win-win scenario, right? If you are a city planner, then you are looking for ways to optimize the traffic flow through your city. If you are somebody who lives downtown, you don't want to hear idling vehicles constantly. There are questions around the pollution impact, the emissions impact of those vehicles. And there, of course, then is the pure efficiency cost. How do I save time? How do I save mileage, wear and tear on my vehicles? And how do I ensure that my drivers have a low stress or straightforward delivery experience? So that's kind of the world that we're looking at. We're looking at a dramatic increase in the need for last mile delivery services and the need to fulfill those services. And the problems that we're trying to solve, how do we figure out exactly how to make those deliveries, have become more complex as we need to take into account the traffic conditions in cities, changing road conditions, incidents, traffic, all of that we need to then pull together to find the optimal way to come up with a route. So that's really what we are specifically talking about when we're talking about tour planning. So here has a tour planning API that is really focused on solving this problem. So what is the tour planning API? So if you are looking for, you can imagine if you have 10 stops that you need to make today, and you want to find the best way to get between those stops. This is a traveling salesman problem. It's not, of course, mathematically possible to know the exact fastest way, but you can get down to an optimum. When we scale that to multiple vehicles, multiple salesmen, that's when things become increasingly complex. So this is known as the vehicle routing problem. And what you would be targeting here is a case where you have not 10, but 1,000 or 10,000 stops that you need to make today or on a shift. These could be deliveries, they could be pickups, they could be, service jobs. So you are you're a technician, you are some company that is doing regular repair work along, to your customers, and you need to figure out the best way to serve those. So you need to figure out how to make all of those stops, those jobs, those deliveries, whatever they are, with the vehicles and the drivers in your fleet. So a lot of different factors need to get fed into there. One of those is the nature of the fleet itself. Where is the depot? What vehicles are there? What drivers are there? What is their shift time? Are there qualifications that need to be taken into account? So you can imagine if you are delivering goods that need to be refrigerated, then anything that needs to be refrigerated should go in a vehicle with a refrigeration unit. And perhaps you need to have a driver who is certified to handle particular kinds of goods. Those are all parts of the problem that get attached to the jobs themselves. Where are they located? When is the customer going to be there? How long will it take to complete it? Is there some kind of, is this a kind of situation where you need to pick up something first and then go to the customer? So when we combine all of those, when we have the jobs, their location, their times, their specific requests, their specific demands, and then we can match that against the vehicles in the fleet, then we can take the current traffic conditions or the predictive traffic conditions if we're looking further out into the future and figure out what is the best way for all of those stops to be allocated across the fleet. Now, why is that important? I guess it should really be obvious, but this is something that lowers costs directly by maximizing the efficient utilization of the fleet. So you want to know more or less what's the fewest number of vehicles I need to complete all of the stops that I have to do today. But if you can do that accurately, then that also leads to increased customer satisfaction because you have more predictable ETAs and those ETAs are more accurate. And you can adapt to changing conditions. So a customer is not available. Rather than that causing cascading problems through the rest of the delivery sequence, you can then optimize and correct for that. That real-time planning adds flexibility and it reduces the impact of exceptions. And crucially, this is something that can be done in an automated way. So in the past, these tour plans would have taken hours to compute. But by automating it, we can reduce that to a matter of seconds or minutes. These really complex problems become boiled down really simply. And this is something that there is, of course, as with all routing questions, there is a garbage in, garbage out scenario. So having the high quality data available in the Here platform, information about truck routes, information about truck attributes, specific environmental zones, road closures, current incident information, current traffic, is really something that ensures that those ETAs are canonical, reliable, and that they can then be connected to other services. So, for example, the mobile SDKs were mentioned, and this is something where you can imagine the value of having a tour plan, having that route sequence, and then being able to share it directly to the driver so that the dispatcher and the driver know that they are both working from the same information. So that allows us to power several different use cases, and I divided those into the operational case and the planning case. So the operational cases, these are things like on-demand services. So there has been pressure for companies to offer same-day delivery, or for kind of newer services like return logistics. So you can imagine you're a clothing retailer and you want to be able to collect clothes that don't fit or that people want to return. These things are areas where retailers can differentiate, but in order to do that effectively, they need to be able to provide high quality routing. So tour planning is a way that they can easily do that. As an API, it's very simple. So you can provide that kind of real-time routing and that multi-vehicle planning with, you have a job list that's a CSV file or a JSON block that includes the data about the fleet and the data about the jobs. And what you get back from that very simply is just a list of those routes in sequence. So no matter what your existing technical backend is, what your business logic is, it's possible to adapt that to tour planning and then really have that kind of turnkey way to see the best way to optimize your vehicles. That's important from the operational case, but it also improves the ability for fleets to plan. So there is, on the one hand, as I mentioned, the increased efficiency by reducing the number of vehicles that are required to serve jobs, by reducing dispatcher workload, by reducing driver stress. But also think about the forecasting optimization, being able to know what things will look like next week, or to really have clear visibility into how your vehicles, your drivers, your delivery fleet is performing. So that's more or less what tour planning is. I think the easiest way to show that is to show you directly what it looks like. So what that would be, so tour planning, as I said, it's a headless API, but this is an example of what it would look like. We have 70 stops here. We have the shift that we've defined, so you can see that the shift runs from 8 o'clock to 6 o'clock p.m. We have the vehicles that we've identified, and then when we click Plan Tour, what we get from that is an allocation of those jobs across 5 of the 10 vehicles in our fleet. And again, that's key. That means that of those 10 vehicles, we didn't really need all of them to make these deliveries. So now imagine what happens if we want to shorten the shift time. Let's say we want to deliver this within a 3-hour shift. Then we can see that the number of vehicles required goes up, but it is possible to do so. And you can see as well that the total distance covered increases, which means that the total duration, the amount of time that we have to pay drivers, and the total delivery cost also increases. And when I talked about forecasting, or when we talk about these kind of digital twins, the idea that you reconstruct a digital version of your real-world operations, you can see how that would be useful. Let's say that we are, like many last mile companies or retailers, looking for where we want to invest in real estate, where we want to put our warehouses. Well, we can see in this case, again, looking at a longer shift, what would happen if we moved the depot downtown? We can then rerun that exact same calculation and compare it to what it looked like before, see that moving that, to this new location would save us time, would save us cost, and would save the amount of distance driven, which is something that reduces our mileage, our maintenance, the wear on the vehicles, and the fuel consumption. So that is kind of end-to-end what tour planning looks like, why you would want it, how it would work, the scenarios in which it would be used, and kind of a demonstration of what specifically that looks like. And with that, I'm open to questions, and I see that some are already coming in. I see that there's a question: what is the impact of the influence of traffic jams on replanning those deliveries? So this is something where I think it largely comes down to in previous scenarios we would have seen areas where a particular problem, being delayed to a delivery or being delayed finding parking, would then cause the deliveries in sequence to become delayed. So this is an area where really you want the information about the traffic jams if you are replanning something in real time. The flip side of that is that once you've created a route and you've sent it to the drivers, if the drivers are using, here a service like Here Last Mile, which includes a driver app, then they have information on those traffic jams and can route around them. And then that information on what the traffic looks like is also visible to the dispatcher, which means you can kind of close that visibility loop.